All right, let's solve example 4 here, which is, of course, a variation of example 4 in your book, which comes from section 5.2. All right, it says solve the system of equations by substitution. And we have two equations. They don't look too particularly difficult to solve. So let's go to our 5 steps. I think we'll find out, though, that we end up with a special case. So step number 1. Step number 1 says solve one of the equations for one of the variables. If possible, solve for a variable that has a coefficient of 1 or minus 1. Aha! That's the only one there. So we're going to solve for that variable in that equation. So we're going to go to equation 1, and we have 2x plus y, which we're going to solve for, equals minus 3. Subtract the 2x, so we're left with y. And of course, if I do it to one side, I must do it to the other. That goes away. Y equals minus 2x minus 3. All right, that's step 1. Done. Step 2. Substitute the expression found in step 1 into the other equation. All right, step 2. All right, so we used equation 1, so the other equation must be equation 2. And we are going to substitute this expression here into equation 2. We can do that. First we have to copy equation 2. 6x plus 3. Let's leave some space here so we can substitute this guy into there. And the right-hand side is going to be 0. Left-hand side is going to equal 0. So I plug that in. I get minus 2x minus 3. Alrighty. I think I did this. You should obtain an equation with one variable. Yep, all I got is x's. Step number 3. Solve the equation. I can do that. Step number 3. Alright, first I'm going to break down the parentheses by distribution. So I get 6x plus 3 times minus 2x is minus 6x. Plus 3 times minus 3 is minus 9. And this all equals 0. Alright, I want to solve for x. So let me combine like terms. I have a like term and I have a like term. 6x minus 6x equals 0. This is interesting. Minus 9 equals 0. Minus 9 equals 0? That is not true. Okay? Since that is not true, we say that this system of equations is inconsistent. That means no matter what we put into x, we're going to get something that is not true. It is not true. Okay? Which means since it's going to, no matter what we put into x, we can't find a solution. Why is that so? Well, let's look at equation 1. Equation 1 is 2x plus y equals minus 3. Let me subtract 2x from both sides. Minus 2x. So now I have y equals minus 2x minus 3. Alright, that was equation 1. Now let's do the same thing. You'll notice I'm converting it to slope-intercept form. You'll see why in just a second. Alright, what's my second equation? My second equation is 6x plus 3y equals 0. 6x plus 3y equals 0. Alright, I want to get rid of the 6x on the left-hand side by subtracting it from both sides. Okay, and I get what? That goes away. I get 3y equals minus 6x plus 0. I don't need that 0. So I'm going to erase the whole thing. So I have 3y equals minus 6x. All right, let's divide by 3. Divide by 3, so we get it in a slope-intercept form. This goes away. So now I get y. 3 goes into 3 once. 3 goes into minus 6. Minus 2 times. So I end up with minus 2x. And there's a 0 hanging out here. Now, notice this. What is the slope of this equation? The slope of equation 1 equals minus 2. The slope of equation 2 equals minus 2. They have the same slope. If I were to plot these little buggers, it would look something like this. Here's my x-axis. My x-axis. My y-axis is here. Minus 3. Alright, so that's 0 minus 3. And it goes down rather steeply, so it's got a negative slope of 2. Looks something like this. This goes through the point 0. Right? There's a 0 here. So that's my intercept. And it's going to go down at the same slope. The two lines are parallel because their slopes are the same. That's why we get an inconsistent answer. This is, about as inconsistent as it can get. Minus 9 is not equal to 0. So, no matter what I put into x, there's no solution for this. This is the special case of parallel lines. Alright, I've done one. I've done example 4. Why don't you do example 4? Good luck!